Hello everyone. In this video, I'm going to discuss factoring sum and differences of perfect cubes. Before we do the factorization, I would like to remind you what is a perfect cube. So when we think about the numbers and we think about the perfect cubes are those numbers whose cube root is an integer. So cube root is an integer. So integer means cube root is like a number like 1, 2, 3, 4, or it can be negatives, but no fractions. So these are all integers. And for example, if you think about 27, is that a perfect cube? So what we do, we take the cube root of 27. This is also known as third root, same thing. And you can even use your calculator, or you can factorize 27, which is 3 times 3 times 3. So 27 is 3 cube, and then we have the whole raised to power 1/3. And we know that when you have power of a power, powers are multiplied. So in this case, 3 and 3 gonna get cancelled. You're gonna have 3. So this is an integer. So cube root of 27 is an integer. So 27 is a perfect cube. Similarly, if we think about some other number like 125, so cube root of 125, so that would be 5, because 125 can be written as 5 cube. And in case of algebraic expression, we say that an algebraic factor is a perfect cube if its power is divisible by 3. For example, if we think about, let's say we want to work with 27x6 y cube, and we are interested in knowing if that is a perfect cube. So we're going to take the cube root of this whole thing and see what we get. So cube root means the power 1/3, and when you have so many factors inside the bracket and all the factors are raised to some power, so when you open the bracket, each factor gonna get that power. So x6 gonna get the power 1/3, y cube gonna get the power 1/3, and then the power of a power they multiply together, so we get 3 x square here, because 3 times 2 is 6, and similarly y. So this is the cube root of 27x6 y cube. And when you get the powers that are divisible by 3, then that algebraic expression is perfect cube. So basically what we did here is we divided each power by 3, and we got our answer here. So we're gonna divide each power by 3. So all the algebraic factors whose powers are divisible by 3, they are perfect cubes. All right, so this is the definition of perfect cube. Now we're gonna do factoring using perfect cubes. For the factoring of perfect cubes, we have two formula. First formula is the sum of perfect cube. So if you recognize two expressions as perfect cubes and you're talking about their sum, so then you have, so let's say x and y are such two perfect cubes. So x cube plus y cube is equal to x plus y. So that's one factor times x square minus xy and plus y square. So we have to have these two factors, and these two factors you cannot break it further. So just so that you know, this expression is a prime factor. You cannot factorize it further. So this is a prime factor. Yellow cube plus blue cube is equal to yellow plus blue times yellow square minus yellow times blue plus blue square. And I'm using the color coding so that when we do the questions, if you have anything else in place of x, you know what that new expression is, and you're going to use that whole bundle together. Similarly, if we have the difference of perfect cubes formula, so we have x cube minus y cube equals to x minus y, and the other factor is x square plus xy plus y square. So let's do a few examples. We're going to use these formulas for the example. And again, in this case, this is also a prime factor. You cannot break it further. So first we have factorize the following expression, a cube plus 1, written as 1 cube. So this is of the form sum of two perfect cubes. And this is like a cube plus y cube, x cube plus y cube of that form. So our formula was, if you have the sum of perfect cubes, the factors are x plus y and x square minus xy plus y square. And just let me remind you, in this case, in place of x, you have a, in place of y, you have 1. And I'm just writing the color coding so that you can fill in the blanks when you do the factoring. So in this case, it should be yellow plus blue, yellow square minus yellow times blue plus blue square. And once we do that, we have a plus 1, a square minus a plus 1 as our factors. And it's always a good idea to check if you have done it correctly, so you can always verify. So you can do the multiplication of the factors and see if you get the original expression back. In this case, we can do, first we can take first member of first bracket, so, and bring it with every member of second bracket. So a times a square is a cube, a times minus a is minus a square plus a. Similarly, you're going to take the second member and multiply it with everybody in the second bracket. So 1 times a is a square minus a plus 1. And in this case, we can see that a square and a square is gone. Similarly, positive a, negative a is gone. And in the end, overall, we have a cube plus 1. So this is the verification that we have done our factoring correctly. Okay, let's try a few more. So next one is 64s cube minus 27t cube. Again, so first step is you have to recognize whether this is of the form perfect cubes. So in this case, so we have to think about, is this of the form some cube minus some other cube? And now our question is, what should be inside the bracket? So one of the tricks is you can see what is the cube root of 64s cube. So what number we get when we take the cube root? So cube root of 64 is 4 and cube root of s cube is s. So it means the number that should go here is 4s. So the cube of this whole thing is 64s cube. Similarly, if you think about 27t cube, so cube root of 27 is 3, cube root of t cube is t, so we get 3t whole cube. So now we can see that this is of the form x cube minus y cube, and we learned that the factoring can be done for the difference of cubes. You do x minus y, x square plus xy plus y square. So we're going to use that formula. So just remember that in this case, in case of x, you have 4s. In case of y, in place of y, you have 3t. And you use your numbers accordingly. So we're going to use the formula x cubed minus y cubed. So we have x minus y, so which means 4s minus 3t, then as x square plus xy plus y square. So we get 4s minus 3t, and here we get 16s square plus 12st plus 9t square. So these are our two factors. Again, if you have extra time, you can always verify by multiplying it back and see if you get the original expression. Let's do a few more practice questions. Think about if this is of the form of sum of perfect cubes. Is there anything that I can put in the brackets such that I get this of the form? Something in the bracket, the whole cube. In order to do that, remember, I told you guys that if you have any power which is multiple of 3, you can always take the cube root of this by dividing the power by 3, which means in this case we get a cube. So here we should have a cube, the whole cube. Similarly for b cube c12, when we take the cube root, so b cube, so b raised to power 3 over 3 and b raised to power 12 over c raised to power 12 over 3, we get b raised to power 1, c raised to power 4. So here you are getting b c raised to power 4. So now this is of the form x cube plus y cube, and we know that x cube plus y cube is x plus y, x square, and then you change the sign, negative xy plus y square. So we have this form. This is your yellow, this is your blue, and see what you have as the replacement in your question, and you're going to use it accordingly. So in this case, in place of x, we have a cube. So take that whole thing. In place of y, you have bc raised to power 4. So apply your formula carefully. So x cube plus y cube, x plus y, so it means yellow plus blue. Then we have yellow square minus yellow times blue plus blue square. So overall we get a cube plus bc raised to power 4, a raised to power 6 minus a cube bc raised to power 4 plus b square c raised to power 8. So whenever you have a square power outside the bracket, so each factor inside the bracket gonna get that power. So that's why we have b square c8 in the end. One more. All right, so if you first look at this question, so you see that the power is a raised to power 4, and then we have a and b raised to power 6. So a raised to power 4 does not look like it's a multiple of 3. But whenever you do factoring, the one thing you should always keep in mind, the first step is if there are any common factors, take them out. So don't forget, take any common factors out first. So that should be always the first step. So in this case, between 16 and 2, so 2 is a common factor. And in the first expression you have a raised to power 4, in the second expression you have a, so you can also take a as a common factor. So you're left with 8a cubed for the first expression, and for the second term you're left with b6. And now our goal is to factorize, so factor this. And in this one we can see that, so 2, so 8, right? So if you think about cube root of 8a cube, so cube root of 8 is 2, cube root of a cube is a, so this is a perfect cube. Similarly, if you take cube root of b raised to power 6 and you divide the power by 3, so you get b squared. So this is of the form difference of two perfect cubes. So I can rewrite this as 2a cube minus b squared, the whole thing raised to power 3. And what was the formula for the difference of two perfect cubes? The formula was x cube minus y cube. So first we start with negative, so x minus y, and then we have x squared plus xy plus y squared. So remember, in place of x you have 2a, in place of y you have b squared. So in this case, when we apply the formula, we get 2a minus b squared. And then for the second factor, we get 2a squared plus 2a times b squared plus b squared whole square. So we have 2a times 2a minus b squared times 4a squared plus 2ab squared and b raised to power 4. So these are our factors of the given expression. So few things about when you recognize two expressions as sum or difference of perfect cubes, you can use these factoring formulas to factorize them. And for any question, don't forget to take any common factors out for any factoring question. So that should be the first step. I hope that makes sense, and I'll see you guys next time. Bye for now.